Okay, so we are on question 9. Now we're given that functions f and g are such that fx is 2 minus 3 sine 2x between 0 and pi, and gx is negative 2 times fx, also between 0 and pi. A. State the ranges of f and g. Okay, before stating the ranges of f and g specifically, let's have a look at what the ranges would be for a basic sine graph, since we're working with sine anyway. So basic sine graph looks like that, right? And that is 1 and negative 1. So it's just between negative 1 and 1. But this is from 0 all the way to 2 pi. That's what normal sine x would be, sine x. We are now looking at sine 2x though. So sine 2x is just squashed tighter, like this. Okay? So sine 2x, let me actually just redraw that. Something like that. Okay, so that is now at pi. So we're looking at this green one. So that one is usually normal sine 2x is between negative 1 and 1. So now let's apply what we have here. So first, let's multiply it by negative 3. So multiplying by negative 3 on all the sides, so negative 1 times negative 3 is positive 3, but then we have to switch the sign around. So I'm just going to move it to the other side. Negative 1 times negative 3 is 3. And the same here. 1 times negative 3 is negative 3. And then in the middle, we'll also multiply by negative 3. Let me just make more space here. So negative 3 sine 2x. Okay, then what do we also need to do? We need to add 2. So we add 2 to every side. So negative 3 plus 2 is negative 1. Negative 3 sine 2x plus 2 is 2 minus 3 sine 2x. And 3 plus 2 is 5. So that is our range, from negative 1 to 5. And let's just write it in the way they want. They want for fx, so that whole thing is fx. Oops. So fx is between negative 1 and 5. Okay, good. Now we also need for gx. So gx is just negative 2fx. So gx, we can start with what fx was. So fx was between negative 1 and 5. And then we're going to multiply by negative 2. So again, negative 1 times negative 2 will become 2. And we have to change the sign, so we move it to the other side. We have this times negative 2. And then also 5 times negative 2 will become negative 10, and we move that to the other side. And again, negative 2fx is just gx, so we can say that gx is between negative 10 and 2. And that's the gx range. Okay. The diagram below shows the graph of y equals fx. Okay, so this graph y equals fx. And then sketch on this diagram the graph of y equals gx. Okay, so gx is just negative 2 times fx. So we just take every y value that we have and multiply that by negative 2. Okay, so this y value here, whatever that y value was, so that y value was 1. But, or not necessarily 1, but whatever this was, times negative 2. So it's just going to be double this distance in the other direction. So double that distance. So over here, let's say. This value, 0, times 2 remains 0. Okay, times negative 2, I mean. This value, whatever that was, we're going to take this distance, double that to the other side. So we'll get something like this. Let's say like that. Yep. 0 again times negative 2 remains 0. And whatever this value was, so this distance, double that in the other direction, so somewhere there. Okay, and again, the same here, this distance, double that in the other direction, so somewhere there. Okay, let's connect them. So, should be roughly with one smooth motion. I don't know if I can do that very well on this device, but yeah, that's basically what it should be. So you just basically mirror the original function because it's negative. So you flip it in the x-axis around, and it's double as high. So whatever each value was here, just double that in the opposite direction. That's probably the easiest way to think about it, I think at least. Okay, now the function h is such that h is g of x plus pi between negative pi and 0. Okay, describe fully the sequence of a sequence of transformations that maps fx onto hx. Okay, so to do that, I would say let's start with first going from fx to gx, and then we'll go from gx to hx. Okay, so from f to g, we multiplied by negative 2. So here, let's just say multiplied by negative 2. So what transformations happens when we multiply by negative 2? Well, okay, multiplying by 2, so the times 2 part, that is a vertical stretch by a scale factor of 2. Not stretch, by scale factor of 2. The negative, what does the negative part do? So the negative part does a reflection, in the x-axis, sorry. So the y values change sign, so it's a reflection in the x-axis, right? If that's the x-axis, if you go from here to here, that's a reflection in the x-axis. So if this y value was 1, this would be negative 1. So the y value changes signs, which means it's a reflection in the x-axis. Okay, then from g to h, so once we have that, from g to h, we just plus pi. So that means we shift pi units to the left. Okay, so plus pi, that tells us shifted pi units to the left. So the plus is to the left, minus would be to the right, to the left. Okay, so I think you could probably combine this into a single transformation, but for 3 marks, maybe it's 1 mark for each of these, which sounds right to me. Okay. Again, that was it for question 9.